This is Mr. Muller for lesson 9-4, quadratics. So kind of like what we did with one of those difficult sections last chapter, we're going to watch some of the Mr. Berger videos and then go through some examples. Again, not some difficult things, but just the vocab is kind of tricky. So I'll kind of sum it up here in a couple minutes for us to watch when we're doing groups. So it's going to ask us about how thick or thin the graph is. So it'll say from narrowest to widest is what the book will use. And really when we're looking at that, we're looking at that a value. So if we have something with the function, that number in front of the x squared. And it's kind of the opposite of what you think. The bigger that a value is, the thinner it's going to get. And that's just because once you start multiplying by bigger numbers, your number starts getting bigger. So then your graph's going to start getting higher and higher and higher. So that's why the bigger it gets, the thinner it gets. So it's going to ask you to put them in order from narrowest to widest or widest to narrowest. And you're pretty much just looking at that number in front of the x squared. So here, as you can see here, it says when absolute value of a increases, so it doesn't matter if it's a positive or negative, it's still going to be narrow or wide. The parabola becomes narrower. When it decreases, it becomes wider. Okay, and we'll kind of talk about that with some of those Mr. Berger videos as well, and kind of go through some of these examples. So if we look here, x squared is where, you're going to have that basic, wide parabola. But then once we start getting into some of these, 4x squared or half x squared, well, I know that this narrow one is going to be the 4x squared. This little bit wider one is going to be the half x squared. And then we're going to learn when it says something like plus 5 or minus 7, that's really where we're starting at the y-axis. So x squared, that's really x squared plus 0. So that's why there's a, our vertex will go through the origin. Now that this says plus 5, we know our vertex is going to go at plus 5. This says minus 7, it's going to go at minus 7. Here's one in color that hopefully talks about the narrowness or the wideness of the graph. So here we have x squared here in red. 1/2 is smaller than 1x squared, so it's going to be wider. And then -3 is going to be, absolute value of -3 is 3, so it's going to be bigger, so it's going to have a narrower vertex than the x squared. So you'll have some questions that ask you how thin or narrow something is, and then it'll ask you to compare them. So when it says to compare them, you're going to be looking at things like how narrow or wide it is, where the vertex is, if it's at, plus 3, like this blue one here, or if it's at 0, because this really says x squared plus 0, or if it's at minus 4, like the green one is. So just some different things to talk about, and I'll give you a list of things to talk about when it says compare. So you'll want to look at the width, the vertex, and probably the axis of symmetry are going to be the big 3 that we're going to compare. And then the last thing we're going to look at is the problem that we've seen 100 times. Usually it's about rocket ships or something and when they launch. So we're going to talk about, this one's a hot air balloon, and one is going at sandbags dropped from a hot air balloon, sorry. One is dropped at 400 feet, one is dropped at 1600 feet, and when they are going to land and things like that. So that'll be the last thing that we explain, and it's the last thing that Mr. Berger will go over in video 3 as well.